Hi everyone, today we will solve the coding interview question to remove the nth node from the end of a linked list. So in this example, we have been given a linked list pointed by the head and it's a linked list of numbers. And we have also been given a number n, which is the position of the node we want to delete, but it's the position from the end of the linked list. And we need to return the head. In this linked list, number 5 is at position 1 from the end of the linked list, and the number 4 is at position 2 from the end of the linked list. 3 is at position 3 from the end of the linked list, and so on and so forth. The most important constraint here is that n will always be less than equal to the size of the linked list. The main problem we have here is we don't know the size of the linked list, and as a brute force approach we could iterate the list and find the number of elements, and that would give us the size of this list. Once we know the size, we can use it to find the position of the element we want to delete from the start of the linked list. So in this case we want to delete 4, and the position will be 1, 2, 3 and 4, which is size minus n, and that will give us 5 minus 2, and that is equal to 3, and that would be 1, 2 and 3. So we've reached here. So we have a pointer, let's say p, and we've reached here, where now we can simply delete the node which is after the current node. I'm going to explain the two-pointer approach because it will allow us to solve this problem in linear time. We'll use a fast pointer and a slow pointer. As a first step, we will initialize the fast pointer to the first element of the linked list. Then in the next step, we will move this pointer n positions into the linked list. So if I move this pointer 2 times, I'll end up here at node 3. I will then initialize a slow pointer to the head of this linked list. And once I've got these 2 pointers in place, I will move both of them 1 position at a time till the fast pointer is on the last element of the linked list. So I'll move both the pointers by 1 position, and the slow pointer will end up on 2 and the fast pointer will end up on 4. And we can see that there is still another node in the linked list. So we'll move both of them once again, and when we do this, we can see that there is no more node after the fast pointer, and we can also see that the slow pointer is pointing to the node before the node that we want to be deleted. So now we simply can say slow pointer next equal to slow pointer next dot next. And now we can simply modify this node 3 to point to node 5 instead of node 4. And that way we would have disconnected node 3 and node 4, which effectively deletes the node 4. So in code, it would look like this: s.next equal to s.next.next. Now let's look at the edge cases. The first edge case is if the linked list contains just 1 element and we have been given n equal to 1, which means we need to delete the only node in this linked list. So in this case, we would need to delete the only node, which is 1, and if we delete that, we are left with null. So we can check that if n equal to 1 and if the node after the head is null, then we can simply return null. So the next edge case is when n equal to the length of the list. That means we want to delete the first element in the linked list, because if you look at the linked list, the size of this linked list is 5, and we are saying that we want to delete the 5th element from the end of the linked list, and the 5th element from the end of the linked list is the first element. In this case, n will be equal to 5. We would initialize the fast pointer to the head of the linked list, and we would need to iterate the linked list 5 times because n equal to 5. So let's say we iterate this fast pointer 5 times. It would end up 5 places from here, which is 1, 2, 3, 4 and 5. So effectively the fast pointer will be pointing to null, and this is our next edge case where after iterating our list, if the fast pointer is null, that means we want to delete the first element of this node. In that case, we would simply move the head one position, so the head would end up here and we would return this head. Okay, so let's have a look at this code, which is based on the algorithm that we just discussed, and I will step through it using the example here to make it easy to understand. So we have a class called list node here, which represents an individual node of the linked list, and the method remove nth from end is the method which we want to execute, and we pass in the head of the linked list and n. So in this case, n is the position from the end of the linked list, and that is the position of the element we want to delete. So we'll first initialize a fast pointer to be equal to the head of the linked list. So we have fast pointing to node 1, and if you look at this for loop here, we will iterate it from 1 to n, and every time we will move the fast pointer to the next node. So in this case, n is 2. So we will iterate this loop twice, and by the end of that for loop, our fast pointer will be at node 3. Then we will initialize the slow pointer, and it will be initialized to point to the head. And now we will move both pointers along the list in this while loop here. We will move both the pointers till the fast pointer is pointing to the last element in the linked list. So by the time we finished executing this while loop, we will end up in this state. Our slow pointer is pointing to the node which is one position before the node we want to delete. Okay, so all we need to do now is say slow.next equal to slow.next.next, and that effectively connects the node 3 to node 5, effectively disconnecting node 3 and 4, which effectively deletes the node 4. And finally, we simply return the head of the linked list. Now let's look at the edge case where we want to delete the fifth element from the end of the linked list. In this case, the length of the linked list is 5. So we are asking the function to remove the first element because that is the fifth element from the end of the linked list. So as before, our fast pointer will be initialized to head here, and we will iterate this for loop 5 times. So by the end of this for loop, we would end up with our fast pointer 5 positions from where it is currently. So which is 1, 2, 3, 4, and then finally here 5. So our fast pointer will actually end up pointing to null. So in our edge case scenario, we will check if fast pointer is null. That means we want to delete the first node here, and the best way to do that is move this head pointer to the next node. So effectively we are saying make head point to this node, which means we no longer have access to this node here, which is effectively deleting node 1, and we return this head here. So hopefully that was clear, and thank you very much for watching. Please remember to subscribe and share and like the video. Thank you.